Bennett, I owe you an answer. You asked what happens when two objects traveling at the speed of light collide. Now, one of the coolest things about physics, the study of how objects move and react to one another, is that the rules that apply to small objects moving at slow speeds are the same rules that apply to large objects moving at tremendous speeds. So to answer your question about the speed of light, we can work right here on my desktop with the objects we have at hand, which in this case are two marbles. Have you seen the toy called Newton's Cradle? It's the row of 5 metal balls, and you lift one up and you swing it down and it knocks the next one up and it goes back and forth like that. That toy demonstrates an important law of physics, which is energy can't be created or destroyed. It can only be transferred from one form to another. So in this case, the ball up here, as it swings down, it has moving energy, what's called kinetic energy. It hits this ball, it transfers all of its energy into this ball, which then moves up, it swings back, hits this one, it transfers the energy back, and that ball comes up, and it passes the energy back and forth. Now, in a perfect situation, each ball would pass all of its energy to the next ball. But in a case like this, the ball, as it swings down, the string might be twisting and turning, so it's losing some moving energy to the string. As it swings down, it's displacing a lot of air, so it's actually pushing air. So some of its moving energy is transferred into the air around it. When the balls collide, they make a noise, so some energy is lost as sound energy. Sound energy is actually just another form of kinetic energy. It's the movement of the vibrations in the air. And finally, there's actually, believe it or not, a small amount of heat energy. When the two objects collide, the friction from them hitting creates a tiny amount of heat. So some of the energy is lost to heat. And eventually, all that energy gets lost in different ways and the balls will stop. Now, if these were moving at each other and collided, even at the speed of light, I want us to try something here. I've got a little bit of a experiment set up. Bear with me. Now, I want you to try this at home if you can. I know we don't all have all the materials we'd like at this time, but if you have anything even remotely like this, try setting this up and do your own experiment, okay? All right, I'm gonna swing over my desk lamp. All right, we're gonna take our string, hang it over the lamp. We're gonna take the marbles and tape it to the string. Okay. Not bad. Aha. All right, let's have the center of the balls be at the 20 centimeters, and we'll measure and see how far up each ball swings. I'm gonna freeze frame that on the widest part of the swing so we can see if it's identical. I think we can say two objects colliding with each other will bounce off with the same amount of force. But one thing we didn't really talk about was the idea of the heat generated. Now, if two objects are traveling at the speed of light, the amount of heat generated in friction from the collision, the transferring of moving energy to heat energy, I think would be so great that it would instantly vaporize both objects. So as you try this experiment at home, I want you to have fun, but please do not vaporize anything in your house. Thanks for the question, Bennett.